good evening. And today we will be starting a very important session. So, so today is a Terraform Day 8, right? And today's very important topic today is a Terraform State Management. Very important topic, sir. And this has been asked many times in an interview. Basically, what happened, right? Basically, the interviewer himself, he will try to confuse you with this topic, actually. Okay. A lot of questions will come with this topic actually. So what is a today's topic is Terraform State Management. Now, so let's take an example, Salik. For example, now suppose assume that there's a company. Okay, there's a company by name something like you can take any company name, like for example XYZ. There's a company XYZ, and basically they have got one project from some client where the client asks, like, I need to set up some resources into the AWS cloud actually. So you have AWS cloud, right? You have AWS cloud, and the particular client, he requests from this company, XYZ company, that he need to create some resources basically. Like for example, you want to create, he need a EC2 servers or EC2 instance. He need a S3 bucket. He need a load balancer. He need DynamoDB, right? He need like VPC. He need to create some security groups. Lot of resources are there, right? Basically, he want to set some kind of a mini data center. He want a data center where he can, create a project. So that is a requirement, okay, which comes to this XYZ company. Now, obviously, what happened, like the XYZ company, he has its own AWS account, right? This is a AWS account he has. So he will try to create whatever the requirement has come from the client in his AWS account, right? So to do that, basically, what the company XYZ will do, he will try to hire some engineers, DevOps engineers, right? Like for example, he will hire some 3 engineers, right? I can take a name also. For example, let us just type names. What names you can give? So I'll say something like Naresh is one of the engineer, DevOps engineer. Second is Mahesh, and what else? The third engineer is Suresh. So these are the 3 engineers who have been hired by this company. And what he will say that the project manager will say that he will give the requirement, a specific requirement to all these engineers, and he will say that please set up or please create a Terraform file, so that with the help of a Terraform file, you can able to create the resources in the AWS cloud, right? So that's what the project manager has given to these engineers. And when these engineers are hired, obviously they will give the laptop to them, right? They'll give some machines or laptop to all these 3 engineers, right? They'll give all the laptops to all these 3 engineers. They'll give the laptops. And you know that in this laptops, it could be a Windows or Mac or Linux, any operating system might be. They have to install the software, means Windows software. On top of the Windows, you know that they have to install the Terraform also, right? So once the Terraform is set up, right? Once the Terraform is installed, right? Now what happened? These engineers like Naresh, he can start writing a Terraform file. So to do that, to write a Terraform file, what he will do, right? First, he log into the system, and basically what he will do, he will try to create one directory. Actually, what he will do, something like this, mkdir, uh, and the project name is something like what the project manager will do, right? He will create he want to create a project with the project name something like project A, something. So what he will do, what Naresh will do, like, so he will do a kind of a, he will create a directory like this, okay? Mkdir, say slash project A. So he will create a directory, and then what he will do, he will try to do a CD onto the project A. Then what the next he will do, he will try to write a Terraform file, something like he will try to create a Terraform file with something like vi project A dot tf, right? It should end with a dot tf, right? It's a Terraform file. After that, what he will do? He will try to do a Terraform init. This we know very well. And I think I will write it over here, sir, actually, because or else I can continue here itself. But because this a font is big, right? It is crossing here. So after Terraform init, he will say Terraform plan, and after that we will say Terraform apply. Correct? We know all these commands. Correct? Terraform init, Terraform plan, and Terraform apply. So these are all the commands what Naresh is going to execute it actually. Now you know very well that whenever he does a Terraform apply, what the Terraform apply will do, it will try to connect to this AWS cloud, because like in the Terraform file, TF file, you know very well that we have provided a access key and the secret key, right? And we have also mentioned what are the providers. So basically, I'm choosing AWS cloud. Hence, what happened in this project A.tf, you have mentioned what are the providers. Like you'll say the providers is AWS, and inside the AWS provider, you have mentioned the secret key and the access key, right? So it is something like whenever you want to create the resources here, you need to basically land into this AWS cloud, right? To land or to log in, to have a credential or to log into this AWS cloud, you need to provide the access key as well as the secret key. So that we know very well, we have been doing from the day one onwards, right? So as soon as the Terraform apply is done by the Naresh, what happened, right? It's going to land into this AWS cloud, and what it does, you know very well that it is going to create all kind of resources like this. So it will create a EC2 instance, it is going to create a VPC, it's going to create a DynamoDB, it's going to create a gateway, it's going to create a elastic load balancer, elastic block storage, whatever the resource is required, some 30, 40, 50 resources, whatever the resource required, or whatever the resources which you are mentioned in your Terraform file, that it will get created. But how exactly it happens actually? So what initially it happens, right? Whenever you are doing a Terraform apply, what Terraform apply will do, first it will try to check you are under which directory. So it understands that you are under the project A directory. Correct? It's under project A directory. You are inside the project A directory, and inside the project A directory you are having this project A.tf file. Okay, but how it happens, basically Terraform apply will try to first check initially in which directory you are in. So you are in a project A, fine, okay. Now what happened in turn, the Terraform apply will try to check within the project A directory, is there any file with the name Terraform.tf state. You try to check this file. Is there any file with this name? No, there is no file with this name. It means that you are actually building a fresh project, or you are building you are actually running a fresh Terraform apply. For the first time you are applying it. So basically this file will not be there. But always what happens, like whenever you're doing Terraform apply, it will always check for this existence of this file. So what will happen that, again I'll tell you, it will try to get into this, it will try to understand that where exactly the Terraform apply has been executed. It means that it's going to check in which directory you are actually running the Terraform apply. So you are running under the project A directory. So inside a project A directory, this Terraform apply, it is going to check if there is any file with the name Terraform.tf state. It will check. Now it will get to know that there is no file with that name. Now what will happen, the Terraform apply will understand, okay, I need to create a fresh resources. I need to I need to apply a fresh resources. Hence what it will do, Terraform apply will try to connect with your AWS account, and then whatever you have mentioned in a Terraform.tf file, it will try to create all those resources like this. Correct? Once all these resources created, once it is completed, what Terraform will do, it will try to collect all the information about all these resources. It will try to collect it. Terraform itself will do it. It will collect all this information of all these resources, and finally what it will do, right, it will try to return all those information about each and every resources, and it will try to write into this Terraform.state file. We'll try to write all this data into the Terraform state file, right? And then what happened? This Terraform state file will get created. This is a file. It will get created under the project A directory. It will get created here under the same path or on the same directory where you are running your Terraform apply. Clear, sir? So basically what happened, right? This terraform.state file, it will keep the information about what are all the resources which are being created by this Terraform file, and what are the resources which are up and running or which are existing in the cloud. That information or that state of the whole resources will be kept within this terraform.tf state file, right? And then what happened, that it will get stored into your local directory or in that present working directory. Now the question comes, actually, why we need this file actually? What is the use case of this file? So in interview they might ask you, okay, fine, terraform.tf state is there, but why you need it basically? So now what will happen, that what Naresh will do, he has applied the Terraform apply, he has executed this command Terraform apply, and then it has created all the resources. Finally it has returned the Terraform tf state file. That is okay. Now again Naresh what will do, he will try to again do a Terraform apply. Now this time what will happen, that when he does a Terraform apply, the same stuff happens. Again this command Terraform apply will check under which directory you are under in. Okay, you are under the project A, fine. Under this directory, it will check, is there any file with the name terraform.tf state? Yes, this file is there. Yes, okay. Now, what are all the configuration which he has mentioned in the Terraform file? Okay, is those configurations information what he need? It is there in the Terraform current Terraform TF state? Yes, it is there. So it means that whatever he needs, if everything is there in the same TF state file or the Terraform state file, then the Terraform apply will say that nothing to be done. It means that it just refresh the state and it will try to understand that okay, nothing is there. He has simply applied it one more time. He has applied it, and that's the reason what happened. That it will not have any changes, right? It will return a status that no more changes to be done, right? That's all. Now, that's what we're discussing. That what is the use case of this Terraform TF state file? Now assume that actually that you have applied the Terraform apply. Terraform apply has created the resources, okay, and assume that for some time, assume that the Terraform TF state file will not get created at all. Okay, so Terraform apply has did its job. It has created the resources, and finally what happened? It has written. Okay, fine. So what Naresh will do again? Naresh will go to the project A.tf. Now what happened? Currently, he might have created some 10 resources actually. Means he has created some 10 resources. Fine. Now what happened, right? He will say that Rajesh, I want to, add 3 more resources. It means that I need to create 3 more resources. On top of this 10 resources, I want to create 3 more resources. So he will do the changes into the same Terraform file. He will add 3 more resources. Okay. And then what he will do, he will try to do Terraform apply. Now what the Terraform apply will do, that assume that this Terraform state concept is not there, this file itself is not there. What the Terraform file will do, it will try to read this projected.tf. It will try to see that okay, it has been changed. Okay, but what it will do now, it will try to create 1 more resource of this complete resource what has been asked, 10 plus 3, 13. So 13 resources will get created again in your AWS account, right? Earlier it was 10, now it has been 13. It means it is a kind of a duplicate resource has been created 1 more time. Similarly, 1 more time you do apply, 1 more time the resource will get created. You apply as and when you keep doing apply, it will keep creating resources. So this should not happen, right? Basically, so this is the wrong way, right? It should not happen. That's a reason to maintain the state of your particular resource, which you are, which you are getting created from your Terraform file. To maintain a state of that particular, you need to have one file actually, which is maintained. So this state is maintained. This is a terraform.tf state file, which is maintained by your Terraform itself. So that's the reason. This is the use case of your terraform.tf state file. It means that you need to have this file, sir. Without this, what happened? Unnecessary, the resources keep getting created. You won't get track at all. So that is the use case. If anybody asks you, you have to say like this actually, right? Now what happened, right? Now what the Naresh did, right? Earlier, okay, we'll come back to the same use case. That now for the first time when he created the 10 resources, fine. Now what happened, right? He has added 3 more resources into the same project.tf file, and then he is applying, he's doing a Terraform apply. Now when he's applying, what the Terraform apply will see, that Terraform will apply will check whether there is any file by name terraform.tf in the project A. Yes, it is there. Now, but the user is asking, apart from the existing, he is asking 3 more resources. So what the Terraform will do, that whatever the difference is there, it does a comparison of the project A.tf with the Terraform state file. So Terraform state file is having that information about the 10 resources which are being created, right? Which already got created. But later what happened, that user, that is nothing but Naresh, has added 3 more resources. So now what will do, that actually Terraform apply will try to do the changes to this existing resources, or to this existing itself. To me that here again 3 more resources will be added, right? Once 3 more resources will be added, now what will happen, right? All the informations of these resources will be collected again, and again what happened, right? It is going to append, or it is going to write into the terraform.tf state file. But before it appends or it does the modification for the terraform.tf state file, what it will do, right? It will try to copy the older data, okay, older data into a file by name terraform.tf state dot backup, like this. So we'll try to create a file, one more file with the name. So whatever the older information was there, that would be written into the terraform.tf.backup, and the new information about the whole about the whole resources will be written into the terraform.tf state file. So basically, this will have an updated information about your state of your Terraform. This will have a older version actually, right? The older version, right? It means that whatever the first which you created for the 10 resources, right? That information will be there in the backup of file. And now Naresh has added 3 more resources apart from the 10. So totally you are having 13 resources. 13 resources information will be there in your new latest terraform.tf state file. So that's how it always works actually. Now tomorrow again, right? What Naresh will do? Naresh will add 4 more resources. So what happened? There is a difference now. So he will add 4 more resources in the terraform.tf file. Again, he will try to do a terraform apply. So what the terraform apply will do? It will try to check into this project A directory. Is there any file within terraform.tf file? Yes, it is there. But there is a mismatch of this configuration, right? Because this is having the information about only the 13 resources. But now user has edited and he has added 4 more resources, correct? 4 more resources is added. So there's a mismatch. Yes. Now what will do? Terraform apply. It will try to, in the same resources, whatever he has created, right? It will not create a separate one, sir. In the same resources, again, 4 more resources will be added. 4 more resources will be added like this, right? And again, the same stuff. This entire data again, all the data information about each and every resource again will be collected, and it will be written into the terraform.tf state file. But before it is returning into it, first it will make a backup. First it will make a backup of that with this, with the file in the terraform.tf state backup file, and then the new changes or the new resource information, everything will be written into this terraform.tf state file. So this will only have a 2 versions, are actually. That means that you'll max have the previous state information about a Terraform and the present state actually. So this is how it happens. Okay. So till here, are you okay? Did you understood the concept? You understood the use
Yes,
case?
Rajesh.
The use case?
Yes, Rajesh.
Yeah.
And one more question, Rajesh. Say in case we have created 10 resources using Terraform file. Okay. So right now, without using Terraform, if I delete any of those resources, even the same scenario will be applicable.
Sure. Yes. Suppose you have
No.
deleted it. You went
Okay.
and you deleted the resources. I mean, you went literally. Suppose like here in this Terraform file, you have created 2 instances. Assume that EC2.
Okay.
It is created. Now what you'll do? You'll go to the console and you'll manually delete one EC2 instance.
Okay.
Now what happened, right? Now what happened? This resource information, it is there in the Terraform state file, right? but you have went and manually deleted it. Now again you do a Terraform apply. It'll understand that, oh, this Terraform state file. What happens now, sir? This Terraform TF state file, it has a sync with this resource, sir, with this AWS account. It'll try to
Right.
check whatever the resources which is there, whether it is there in this AWS or not. If it is not there, it'll recreate that EC2 instance again. So it will maintain that state always actually. Okay. So always the whatever the information in this there in the Terraform test file, that should match with an existing resource what is being created. If again there's a mismatch, what happened, right? When you're applying it, it will make sure that whatever the data which the Terraform test state has, right, that has to get recreated again here over here. That's all. Because you are applying, right? Again you're applying, right? Again when you're applying, again in the apply you have mentioned the creation of two EC2 instance. But what happened, right? There is no one EC2 instance has been deleted. A user has deleted. It will recreate it again. That's all. Okay. So now, so now what happened, right? Okay, this is all fine. So this is all perfect. It's good that it's going on. Now, what your manager says actually, manager will give you the task of maintaining or writing the Terraform file between all these engineers actually. So even what happened, even Mahesh has to even log into his machine, and he has to get into a directory, and even he has to edit some of the things onto the existing Terraform file, and then he has to do the changes. So because all these people, three engineers, they will be working under the same project actually. So what Mahesh will do, Mahesh the same stuff also he'll also do, sir. He will log into his machine. What he will do? He will also create one directory like this, mkdir slash. He can create any project, but because all are working on the same project, he will also try to create the same with the same name, project A. And he will also do the same stuff, sir. Like for example, he will also go into the directory, cd to the slash project A directory, very well. Now he'll, even he has to edit this file. But ultimately, this project A.tf, it is not there with Mahesh actually. It is only there with the Naresh, because he initiated this project, right? He initiated the project. He started the project, working in the project actually. So what happens that Mahesh, what has to do? He has to take that Terraform.tf file or the project A.tf file from Naresh actually. So what will happen that he has to take that file actually. So how Naresh might give in some pen drive, or he can share into the email where no Mahesh will copy it and he will try to place that file actually. Correct? He'll try to place that file actually. So what he will do, he will try to open the file, and here also he will do some changes into the resources, and finally what he will save the file, and he will do a Terraform init. He has to initialize it, and again he will say Terraform plan. Again he has to do a Terraform apply. Right? So now all the same step, even Mahesh also should do it actually. But the problem here is that there are many problems are there actually. Now what is happening is that actually, firstly what happened that he has to give this file to you. So Naresh has to give. So it means that suppose someday Naresh has not logged in. Okay, he's off actually, and Mahesh is there, and Mahesh has to continue with this project actually. So what he will do that, what Mahesh will do that, he will take this file project A.tf from Naresh actually, and he will go, he'll open that file, he will do some changes in this project, and he will do an apply actually here like this apply. So what will happen, right? Again, what happened, right? When you do an apply, what apply will do, Terraform apply will do in Mahesh machine, it will try to check under the same directory slash project A. Is there any file with the name terra.tf state file? Is there? No. So it will consider as it's a fresh resource. So what it do? It will try to log into this machine, and it will create one more fresh resource. Correct, sir? It will create one more fresh resource actually. Correct? And whatever the things which are there, all those resources will be created here. Correct? It will get created, right? But in the real scenario, it should not happen, right? Because when the Mahesh is working, he has to work on the same resource which is already been created by the Naresh user, right? So what Mahesh has to do is that actually he has to take the project.tf file, as well as he has to even take the terraform.tf state also from him. Correct? Do you agree with me, sir? This one? That means that under this project A, he should place this file as well as this file also. Correct? and then he should start working on it actually. So what will happen that when there is a terraform.tf state file which is given by Naresh to Mahesh, and Mahesh is changing the project a.tf, and when you try to apply it, when it is applying it, it's going to check is there any terraform.tf file is there. Yes, it is there. Okay, what is the difference between the project a.tf with the terraform file? Okay, there are some changes are there. Oh, it will try to do, and it will try to do the, sorry, it will try to do, and it will try to do the changes, it will try to do the changes into this file, into this resource, right? Correct, sir? Do you agree with me? Sir, do you agree with me, guys?
Yes, Rajesh.
Yeah. So now what happened, right? He has to give it. Now, at the end of the day, suppose assume that Mahesh has completed his task of doing certain changes into the project.tf, right? And also he has all those updated stuff of this terraform.ts file. Everything is there, fine. Tomorrow morning, what happened that Naresh will log in tomorrow because he was off yesterday. And tomorrow morning, Naresh will log in. Naresh has to collect again these files from Mahesh, right? Because there has to be coordination between Mahesh and Naresh always, right? Because both these guys are doing the same project actually, right? Assume that again what happened, Naresh has took the Terraform project a.tf, but he forget to take this file, terraform.tf state from Mahesh. Then again he will face the problem. There is no sync happens. So there is a configuration mismatch again. Correct? Because yesterday when Mahesh was working, he created some 17 resources. He has created 17 resources, fine. But tomorrow, yesterday what happened? Naresh had created some more resources added, and those changes he has added some more 5 resources, and those state information is maintained by the terraform.tf state file, and Mahesh was not given to Naresh. So Naresh, what happened? Naresh will take up the project a.tf which is given by Mahesh, and he will try to edit it, and he will try to apply it. When he's applying, there's a mismatch because this Terraform.tf state file, what Naresh is having, there is a mismatch between the Terraform file with this Terraform.tf state. There's a mismatch, and it will lead to some kind of a inconsistent state actually. So this is not a right way, right? Assume that there are only 2 people are there or 3 people are there who are working. Assume that there are some 20 people are there working in a project. Do you think that everyone will start interchanging all these files each other? Oh, Mahesh will say that, oh, take all these files. Then Suresh will ask. There is a lot of disturbance will happen, right, between engineers, right? So this is not the right way to do it actually. Correct? Now what happened, right? So now this is one problem statement. Correct, sir? This is a problem statement. Now, how to fix this problem statement actually? So to fix this problem statement, you have 2 methods are actually. One method is something like you create. There are a lot of methods are there actually, but one of the method is that actually, what is one of the method is that you need to create some separate, storage. You need to create some separate storage. Like for example, I will take a server, I will take a machine, or I will take a machine. Sorry, I'll take a machine. I'll take a server. I will install whatever Windows or Linux here. Now what happened? I will install here the NFS server over here, NFS server or NFS share drive. And inside the NFS share drive, what I will do, right? I will create one, a common share drive, something like common. Okay. And what I will do that, I will tell all these 3, engineers, Naresh, Mahesh, and Suresh that, okay, I will tell that this is your common shared drive. This is your common shared drive. I will tell all these 3 people to them. So now what I will tell that actually, so this is NFS. This is one of the use case I'm saying that how to fix this issue. There are many methods are there. So I'll be telling some few methods how to fix this issue. Okay. Now what Naresh will do that, Naresh will work on his project.tf file. Right? He will add everything and he will do an apply. Once he apply, once the resources getting created, finally a terraform.tf state file will be given to him, right? And now what happened that this terraform.tf file which is getting created, right? What Naresh will do, Naresh will try to place this file or upload this file under this common directory. So here what will happen that this terraform.tf state file will be there in this NFS folder or in this NFS shared drive. Correct? Now tomorrow again, if Mahesh want to work on the same project, what he will do, right? He will take the updated terraform.tf state file from this common shared storage, like from the common NFS. So before he does everything, he knows that, okay, man, I want to take up this file first. I want to take. So what happened that he will try to download this file. He'll try to download this file from your NFS and he will keep it here. And then he will edit this terraform.tf state file and then he will do an apply. Correct? So here, what is important thing is that actually before you start working on it, you should always remember that I need to pick from the common shared point and I need to place this terraform.tf state file. Otherwise, what happened that there would be some kind of a mismatch will happen in the configuration. So that always he should take care of it. So, but that is a tedious task, right? Because like assume that today Naresh worked for the whole day. Okay, he worked on this project.tf file and he has got his latest terraform.tf file, but he forget to upload into the common directory. Common directory or the common SharePoint, it still has some older file only. Tomorrow or the end of the day, what happened? Mahesh will take up, but he thinks that okay, terraform.tf file, maybe Naresh might have updated it. Okay, let me pull that file and then I'll start working. Again, you could see that there's a mismatch actually. It is basically kind of a human error, right? You will work, you know that I need to update at the end of the day, but you'll forget it. As a human, we'll forget, right? We tend to do mistakes, correct? So here what is happening? Again, there is a mismatch is happening. And one more thing is that actually very important that this is an NFS share, right? You should always make sure that okay, you need to maintain the health of this server. Okay, the server should always be up and running. Fine, that is one use case. Okay, and always like this server should not get in the hang state, because if it get to hang state, no, I will not be able to connect. I will not be able to get the terraform.tf state file. So you should make sure that the health of the server is always up and running, and also you should make sure that the disk space of this common should always be below the threshold. If it is going above, if there is a huge disk usage is happening, right? Then what happened? Again, what happened? This uploading of this terraform.tf file or downloading will become. You have to wait. It will get stopped actually. So again, this is a tedious task, sir. Actually, again, it's a tedious task. So this is again what I would say that this is not a recommended way. Okay. Finally, you say, okay, it was better than earlier, but again, this itself has many issues actually. Correct. So now what will do that? Okay, fine. Instead of this, what I will do that? Okay, what I will do instead of this NFS share drive, I'll do one thing, sir, because you need to maintain only the information about a file, right? Okay. And also, sorry, in the common, what happened, right? Sorry, I think I missed it. One important point under the common, actually, under the common, you know that actually we are maintaining the terraform.tstate file, correct? This file, we are maintaining it. We are maintaining this file, correct? Now, what is happening that because if the people will start doing it, uploading and downloading and all, right? And you are doing a lot of changes to the Terraform file, actually, your NFS should also maintain the versioning also. So versioning means actually suppose Naresh has first updated the terraform.tf state file. Okay, this has a version, something like version 1. Version 1. Again, what is happening is that tomorrow Mahesh, again, he will try to pull this and he will do the work on the project. Again, he will try to push the terraform.tf file. Now it has to maintain the version 2. So you need some kind of a versioning also. Otherwise, how you will know who did what changes, right? You have to maintain the version. Okay, fine. Even though if it's an FS share drive, I will try to even implement the versioning system also with this. Fine, I will implement. As a user, I know how to implement the versioning. I will implement it, sir. I will implement the versioning also. That is also fine. Okay, so I will do it. But again, what is a common issue? What we have seen that here actually that if the server goes down, or if there's a disk issue, or if this is hung state, again what happened? You lead to a problem. And here what happened, right? Because there has to be well coordination. It means that whoever is working on the project, he should make sure at the end of the day, he has to update this terraform.tf state file. If you forget to do that, again the next engineer he will try to pull it thinking that this is an updated one. Again, there's a configuration mismatch, so it will lead to a lot of confusion also, right? So this is what it is. But again, as I said, right, this is not a good method to use the NFS shared drive, right? So what we will do, we know this that we know that we are maintaining the information, only one information, we are maintaining the terraform.tf state file, correct? Why don't we use a GitHub actually? Why don't we use a Git? Fine. What you will do, you have a GitHub, what you have to basically create, you have to create some repository. First, you have to initially create a repository. Okay, repository, you have to create a repository, and you have to make it as a Git version actually. Okay, and later what you have to do that actually, you know that GitHub by default it will keep the versioning. You need not to maintain. You need not to explicitly mention it. It does itself actually, right? Now what will happen that what the user will do, what Naresh will do, Naresh will try to work on the project. He'll same thing. He will apply it. He will get a terraform.ts state file, and that state file he will try to do a push into it actually. He will try to do a push. You know that in Git we'll be using push and pull, right? So what he will do, he will do a push. He will do a push of the terraform.tf state file. He will try to do a push. So he will do a push operation here. Right? He will do a push operation. Tomorrow again, what happened, right? If Mahesh want to continue it, before he does it, he want to do a pull. So he will do a pull operation from your GitHub. He will do a pull operation so that he will get the latest terraform.ts file to work on it. Again, here the problem here is that actually one use case problem is that actually same stuff. Well, Naresh is working. He has worked onto the entire project, and finally he has applied it. But the problem is that actually he has forgotten to do a push actually, right? Similar like how he did in for the earlier case, right, where he forget to upload into a common directory which is maintained by NFS server, right? Here also he might do the same thing. So right, it could be possible, right? He will forget to push it. Again, what is happening is that actually, again what happened, right? Our Mahesh, he want to work on it. So before he work on it, he will think that, oh, let me take the latest one. So he will try to do the git pull so that he will try to pull the latest, but this is not the latest one, right? So then what happened? Again, there's a conflict, there's a mismatch in the configuration, things will not work. Or else assume that all these three people, okay, all these three, Mahesh, Naresh and Suresh, all these three people, they have updated the terraform.tf file and they have applied it. And finally, what is happening that they're getting the Terraform at the same fraction of second. They have gotten the Terraform.tf state file. If they are pushing it actually, so what will happen that Git will allow all the push to be happen. It means that you have a freedom to push it actually at any point of time. Assume that all the three users are doing the push. So what? So let us understand that first Naresh will do the project.tf. He'll do the first. He'll do an apply. He got his own terraform.tf state file. Fine. Okay. Now what happened that Mahesh will take a latest pull, or he will try to even do a changes on a Terraform project.tf file. He will also do an apply, and he will also get a Terraform.tf state file. Okay, fine. Now again, what happens? Suresh will also do, right? So now what is happening is that actually every individual engineers are doing it actually. And finally, where they think that okay, I am is the latest one. Now what happened? All these three engineers, they'll try to do a git push into the same repository. So what will happen that it will overwrite it actually. It will overwrite it, right? So what will happen that so your GitHub repository, okay, it might have the latest of what Suresh has did the changes at the end, or it might have even Mahesh or Naresh. We don't know, sir, because what is happening? There's nothing like a locking here actually. See what will happen that if you're doing a push actually, it will allow everyone to push. But assume that when Mahesh is pushing into the GitHub, at the same instance, even Naresh is also pushing or Naresh is also pushing. It should not allow Naresh to push it, basically. It means that when Naresh is pushing, at the same instant, Mahesh cannot push it. there has to be some kind of a locking mechanism. If this locking mechanism is implemented, like something like I'll obtain something like a lock mechanism, what lock will do, right? Lock will do that. Now Naresh, when he's applying it, when he want to work on this project, what he will do, he will try to do a pull from the GitHub, right? He will try to do a first pull. While pulling, Mahesh cannot pull it. Why? Because if there is a locking mechanism is implemented, it will throw an error saying that already there is some pull operation happening by some other user. You cannot pull it. So Mahesh has to wait it till the pull is completed by the Naresh. Right. So you have to additionally implement this locking technique. Actually, GitHub doesn't provide this locking technique by its own. So again, there's a use case here that you need to separately implement a locking here. Okay. So now, as I said earlier, right? So what? So that's how it is. You have to implement the locking to make sure that the sync is happening between these three engineers. It means that one at a time they can do a push and pull. All the engineers cannot do a push and pull at the same instance. They cannot do it. But assume that you have not implemented locking mechanism. You guys all are doing the same push at the same instance of time. What will happen that it will mismatch it actually. Then all these three engineers will start fighting each other. Hey, where are my changes? Where are my changes? How come you can do a push into the GitHub when I am doing? So there will be a lot of conflict will happen between these engineers, right? So this is also not a right approach. So using GitHub as a common storage or using a NFS as a common storage, this is your local method, sir. You might be thought that okay, let me implement to fix up all those issues what we discussed earlier. To fix it up, you thought that okay, let me implement some local like methods like creating an NFS server, playing with this, creating a common SharePoint and maintaining the Terraform.ts file. That you will do it. But again, as I discussed, like NFS has its own issues actually. Then you overcome from that and you came up with the GitHub. And the GitHub again has its own issues. Actually, there's no locking mechanism, right? And one more important thing, sir, which I missed it. Now, what happened in your project or in your project a.tf file? Assume that you are creating a resource of the DB. One second, sir. Sorry, guys. Yeah, I got one call actually. So here, so one more important use case actually is that actually that in your Terraform a.tf file, you are creating some database actually. You are creating some MySQL database, MySQL DB, right? You are creating one resource where it will create a MySQL DB. And also what happened that you need to provide the username and the password. So it means that you might be placing in the same file, you are mentioning what is the username and the password, or else you might create a separate file by name variable.terraform. In that file also you are trying to maintain it actually. Assume that in the same project a.tf file you are maintaining it actually, right? And what happened that when you try to do an apply onto this, and finally you got the terraform.ts file, this file will also has the information about the username and the password, right? Because this maintain the entire state of your resources, right? So this will have it actually. When you're trying to push it into a GitHub, actually, GitHub is maintaining plainly as a text file. If anyone needs he can actually download this file and he can look into the username and password of the database. So there is no security over here actually. So neither there was a security over here when you're working on system, neither there is a security over in the GitHub when you try to push it. So there is nothing like an encryption method in GitHub where you'll encrypt the data and you will keep it in a GitHub. So that is one one disadvantage actually in GitHub. So again, as I said, right, there are a lot of issues are there using even GitHub as a solution for this. To fix all these issues, GitHub is also not a right choice to do it. Now, so there's a big problem statement now, right? Now what happens that Terraform hashtag corp itself, it itself will give a solution, sir. It itself is giving a solution to fix all these issues actually. What is that actually? What Terraform says that actually, Okay, let me remove this. Yeah, what Terraform says that actually, Terraform says that I am maintaining, or you can create some kind of a storage or something like a backend storage, he says actually. So what is that backend storage? See, you know that Terraform itself has its own cloud, the native cloud. If you're aware of or not, I'm not sure. Terraform itself has its own native cloud, sir. What are those native clouds? The native cloud is nothing but Terraform Enterprise Cloud, sir, actually. Enterprise Cloud, actually. So Terraform Enterprise Cloud itself is a native cloud, actually. So what he says actually that you can use the storage from my own Terraform cloud itself, actually. Or else you can even create a storage from the AWS, sorry, from your AWS. Like you have a AWS storage, right? What is the AWS storage? You have a S3 bucket, right? Similarly, you have a Azure storage, and even you have a Google Cloud storage also. So you can use any of the storage actually. Okay, any of the storage. Okay, so in our example, what we are doing, we will be selecting the AWS storage only, S3 bucket storage. So what he will say that actually that so what this is nothing but it is a backup method. It means that backup storage method. It means that Terraform itself is providing the solution actually for these issues. Whatever we discussed till now, right? The maintaining information about the Terraform state file and also maintaining the versioning. There is no security, there is no encryption, right? There are so many issues are there with this, right? To overcome that, Terraform itself is providing the solution, which is nothing but Terraform. It itself is providing the storage actually, which is you can achieve through the Terraform Enterprise Cloud. Or else, if you're not going with the Terraform Cloud, sir, no problem. You can go with some other cloud also. Okay, AWS, Azure, as well as GCP. So here in this example, I am using the AWS storage. Now, what it says that actually that in a AWS, what you can do, there is one service known as a S3 storage, right? Bucket. So what he says that you create a S3 bucket, sir. Actually, create an S3 bucket. Now, what does S3 bucket do? So, for example, I will create a S3 bucket with my name, with some name, something like my cloud 2022, something. I will create this name bucket with this name. Okay, and then what I will do that, as you know, that bucket itself will provide a versioning actually. It provides it provides a versioning actually. It provides the version. So this feature is by default it is there with the S3 bucket. If some of you know about the S3 bucket, service, right? They know that it provides the version. Okay, so I can use the S3 bucket, and by default it provides the versioning, so that I need not to use any other versioning mechanism to do it. By itself it will give it actually. That is one thing. And second, what happened, right? Your S3 bucket will also provide the encryption. It is all these are all by default features, sir. You need not to explicitly implement anything like this actually, right? Because of it versioning, what will happen that it will maintain the different states, or it will maintain a different versioning of the different each and every state. Like for example, if Naresh is doing any work in a project, and finally what he will do, right? He will try to do an apply, and once he does an apply, what is happening is that actually once it is applying, what will happen that it will create a terraform.tstate file, but it will not create in its local disk. See here, guys. Now what will happen that whenever you are doing a Terraform apply, what it was happening? It was happening that in your local drive or in your local file system itself, the terraform.tf_state file was getting created. Even the terraform.tf_state backup was also getting created, right? So that's what, right? By default, these files will get created in your local drive or in your local file system, all in that specific directory only. And when Mahesh want to work on it, you know that Naresh has to share those files actually, and it was very difficult. Hence, what happened? We came up with some common shared drive. So there is a problem of maintaining the TF files in the local drive itself. That itself was an issue at the first position. Correct? Do you agree with me, sir? Do you have any doubts here till here? Are you able to understand what I'm saying? Forget about the S3 bucket.
Yes, sir.
Forget about S3 bucket as of now. Just to maintain the information about the file in the local drive itself was difficult actually. That is not a right approach, because again and again you need to share the file to across various different engineers, right? To overcome that, we had some common or some local methods. Something like I started creating a NFS share storage, or I was creating a GitHub, and then I was doing some push and pull when it is a GitHub, or else I want to upload or download when it is NFS shared drive. So you are maintaining everything, all those files from your local drive to some storage place or to some specific location, right? Or NFS shared drive, or else it is in your GitHub, right? That itself was something like it is not a good method, right? So what Terraform says that actually you can maintain the information of this Terraform TF state file within your S3 bucket itself. Within your S3 bucket itself, you can save the information. So for doing that, actually, what happened that in your Terraform file, or not, but in your project file, you need to add one more one more method where you are telling, so that we will see later what exactly we will be doing here. What happened in your terraform.tf file, you will be mentioning that, hey, instead of storing the terraform.tf state file in my local drive, don't store it here, you store it in a S3 bucket actually. You got it? So it means that along with your Terraform file, you are adding some more specific feature or some more specific code where you are telling that don't save the terraform.ts file in my local drive, save it under the S3 bucket. So that's what you are adding. What is it? When you see the example, it will get clear, sir. You will get all these things when you are doing practically. Now just to try to understand a theory. So now what will happen that, okay, we'll come back across to the S3 bucket itself now. So now what happened, this S3 bucket or nothing but the backend storage, this feature is stored by a Terraform itself. What the Terraform says that you can use any of the cloud service, like any of the cloud service, any of the storage service of that particular cloud you can use, so that you can avoid many of the issues what you are facing earlier with my method, right? What is that method? He says that, okay, first create an S3 bucket, okay, when it comes to AWS, then create a bucket with some name. By default, it will enable this versioning and encryption. By default, this feature is already there in the S3 bucket. Okay, fine. Now, what will say that go to your Terraform file. Okay, I'll go to the Terraform file. That is a project a.tf. There, you add something here so that it understands that, oh, I should not maintain the Terraform.ts file under my local drive. It has to get saved here actually. To show the code snippet for you, I'm just showing over here actually. See, this is what you are showing. See, in the back end, you are saying that don't create under the local drive. You please create into the S3 bucket actually. Right? This is a code snippet, but later I will tell you. So this code, this entire code, sir, you will be adding in your project A. Once you add this detail in the project A, once you add it, again you have to do a Terraform init. Once you do a Terraform init, Terraform will now it will understand, okay, I don't want to create this terraform.ts file under my local drive. It has to get created as S3 bucket. Like that, it will understand it. Clear, sir? Now what will do that? Now in the project a.tf file, I will add this code along with the other resources and the other providers. What are the providers, resources, everything. And now I will do a Terraform init, fine. Then what will do that? It will try to do a Terraform apply. What Terraform apply will do that actually? Terraform apply, since there is no terraform.tf stated file is there, first time it will go and it will create a resource. So it will go and it will try to create the resource for the first time. Like this, it will go and it will create the resource. Like this, right? It will go and it will create all the resources what a user is required. Like this, it will create. Okay. After it get created, all the information about the resources, it will collect it. And now finally what happened that it has to return that information of the resource and it has to save in a terraform.ts file. Instead of saving under the local drive, it understands that, oh, I need to come and save under the S3 bucket. Oh, it will come and it will save here like this. It will come and the terraform.tf state file, it will get created under the S3 bucket now. Clear, sir? Now what? Now next what happened, right? Now what happened? Okay, Naresh has completed his work. Now tomorrow what happened? Mahesh will start working on this project. Okay, fine. What he has to do, right? This terraform.a.tf file, only this file has to be shared from Naresh to Mahesh. So what Naresh will do? Naresh will share this file only. He will not share the terraform.tf file. It's not required. He'll only share this file. So what Mahesh will do? He'll take this file and he will go and he'll do some changes into the file. Right? He'll try to do a changes into the file. Once he does the changes, he will try to do an apply. Once it applies, what the apply will do, apply will try to check into this S3 bucket. Is there any file with the name terraform.txt file? Yes, it is there. Okay, it is there. So Mahesh had did some more changes into it. What will do that? It understand, okay, I have to do some more changes into the same resource what is being created by Naresh. So it will go like this. So here what Mahesh will do, he'll apply it, and then what the apply will do, it will try to check into this terraform.txt file which has already been there in the S3 bucket. Oh, this file is there. Okay, there is some mismatches there because like he has added some more new resource to be created. So there's a configuration mismatches there. Oh, now it will try to apply it. What are the changes are there, that it will go and it will get applied here. It means that earlier what happened, that Naresh had created some 17 resources. Now Mahesh is updating 3 more resources, like nothing but totally 20. So those 3 more resources will get created. Once it get created 3 more resources, now there are 20 resources are there. That information will be collected. Now what happened, that information again it has to be stored into some TF file here. But instead of creating a local, it understands that I have to create in S3 bucket. Now what S3 bucket will do, that by default the versioning is there. So now what will happen, this terraform.txt state file, it will be pushed into some other older version. A new terraform file with a terraform.txt state will get created like this. So it means that because there is a versioning method is already enabled, it understands that, okay, this is an old file, it will push into some other version, and a new terraform file, a state file with all the new source will be maintained by the S3 bucket. Similarly, what happened, if Suresh is working on the terraform.tf file, now what he'll do, he will do some more changes, because again this terraform.tf file, it has to be shared by Mahesh to both of these engineers. He has to share this file to both these engineers. Correct. So now what happened, that Suresh will also get the latest terraform.tf file. Again, he will try to do the changes. Once he do the changes, again he will try to do a Terraform apply. When he does the Terraform apply, it will try to check under the S3 bucket, is there any Terraform.tf file is there? Yes, the latest is there. Now it will try to check what is exactly Suresh has added the changes. Okay, there are some few changes are there. Okay, there is a mismatch is there. Or it will try to do the changes into the same resource where he is created. Right? Again, it will try to return it. Once it completes all the changes, again it will try to return with the new data. So that new data has to get saved as a terraform.txt file. But whatever the existing terraform.txt file is there, again it will be taken as a backup, because S3 by default it provides a versioning. Like this way, it will be keep doing it actually. So one problem is resolved with the help of a S3 bucket. Correct? What is second? Security, as I said, right? Earlier in the GitHub, when we are pushing the file, right, that file used to have the Terraform, the DB name, username, and password. But here, since S3 bucket, it providing an encryption, by default, all those terraform.txt will be in an encrypted version. If anyone will try to take this file, they will not be able to decrypt it. So you are actually protecting the sensitive data, or you are protecting the security of all the data. So this is also achieved with the help of a S3 bucket. Clear, sir? Till here? So this looks very complex, little complex, but when we are doing the practicals, this is very easy to implement in the practicals. Sir. So conceptually, you understood that it is little difficult to understand or to maintain it, but you understood the overall picture, right? Why we need a terraform.tf state file, right? So in an interview, they might confuse you. So you should not get confused with any of the things. You have to tell that how exactly this terraform.tf file is maintained. So internally, Terraform will be maintained with the help of its own internal storage only, right? So we are using AWS storage actually. So for doing that, a user, or when you are implementing a project, you have to create a bucket actually first, and then you need to create a bucket, and you need to enable the versioning and the encryption. And in the Terraform state file, you need to tell that, okay, for the information about the Terraform state file, it should not get created, or it should not saved here. Instead, it should get saved into the S3 bucket itself, so that you are maintaining the versioning as well as encryption. That's all, sir. Clear, sir? Is it clear, sir?
Yes, yes.
Okay. Now a problem comes here. Again, there are many problems are there. What is the problem again? The problem is that actually that here all these three engineers, are working. Correct. They are working into this project Terraform-A.tf file. They are doing all these changes. Fine. That's okay. That's good. Right. But what happened, right? They are doing an apply into this. They are doing apply. They are changing and they are doing apply. They are doing changes to a live production resources. They are doing a live. It means that whatever you're doing in apply, right, it is not like that no, you are creating some dummy resource, right? You are creating a main resource what is required by the customer, and the same setup is actually it is used by the customer at the same instance of time, right? So this is kind of a live production environment which you are doing an apply, and you are trying to do all kind of a changes what is required. Correct. Now, what happened that your manager says that actually, okay, whenever you're applying, sir, don't apply into this live project. What he says that actually you create something like a stage, actually, stage environment. First, you do an apply to the stage environment. First, you do an apply to the stage environment like this. First, you do an apply to the stage environment. Here, you create all the resources. Here, you create on all resources. Whatever the users there, you play all this you play with everything with the stage, not with the product prod. So this is something like a stage environment, and this is an actual production environment, right? Assume that if you're doing everything changes to production, assume that some engineers like Suresh, he does the changes into the project A.tf file. There are some issue, there are some mistake happened, and he's trying to do a live update to the production. If the production goes down, and at the same instance the customer is using your all your data, if it is goes down, even the customer is not able to access this entire resource, right? This will also go down, right? So in the real scenario it should not happen, right? So instead of doing everything to the live production, so this is not the right way. What it will say that actually first you need to provide, you need to create one kind of a stage actually. Now what it will do that actually, what will happen usually that actually how you can create a stage actually, what. So because Naresh started this project, right? What Naresh will do that in his local drive under this project A, sir, under this project A, what he will do, right? He will create two directories, sir. One is a prod and other is a stage like this. Other is a stage. Okay. And now what he will do that he will maintain this project A.tf under this stage. Project A.tf under this stage folder. See, please understand under the project A folder itself, inside a project A folder, he is creating two more two more directories with the name prod and stage actually. Correct. So under the stage, what he's doing now, he is creating this file. This Terraform file is over here, sir, actually. So it means that what would be the directory structure? Can anyone tell me? So /project A under that you have a stage directory. Under that there is a file by name project A.tf file. Do you agree with me, sir? You agree with me? Yes, fine, good. Okay, it is there. Now again, so what he will do, what Naresh will do that Naresh will go into this path. Okay, he will do all the changes in the project A.tf file. Okay, and in this file he is also maintaining this S3 bucket information, right? And what will happen that he will do a Terraform apply. What the Terraform apply will do that because you are creating a stage actually, it will create a separate resource for the stage like this. It will create a separate like this for the stage. It will create all the resources whatever is required under the stage. Create. And now once it creates, what will happen that all the data or the information about these resources, it will get written Okay, it needs a data, it will get written, and now it has to get saved onto the terraform.state file. Now here it will come and it will get saved over here. Correct? Do you agree with me, sir? Still, you are not gone into the live project, sir, live production. Now, once he confirms, once the Naresh confirms, okay, this is perfectly working fine. The stage environment is working fine. What he will do now, he will take this file, he will copy this file under the prod. So under the prod, what is the directory structure under the prod? Same, sir. Slash project A. Under that, he has created one directory by name prod. Under that, he will try to copy the same project A, project A.tf. You agree with me? He will try to copy this file. Now, Naresh, what it will do that he will try to do a Terraform apply. Now, what that Terraform apply will do? The Terraform apply will try to go and it will try to create a production. He will try to create a production resource. Again, what happened, right? In this Terraform file A, you will say that actually the Terraform-Day-8 file, it should not get created in my local drive. Instead, it has to create some into some S3 bucket. So now what will happen that you will create one S3 bucket. So before you do right, you will create a separate S3 bucket. You will create a separate S3 bucket. S3 bucket you will create. In that S3 bucket, something like my cloud or project A prod, something like the bucket name will get created. Here the versioning is enabled, encryption enabled, everything. Now what will happen that this Terraform, this apply, after you apply to the prod, right, whatever the data is there, that will get written, and finally it will get written and it will get stored into this S3 bucket under their bucket actually, right? And what will get created? It will create this terraform.state file. Right, sir? Now what happened that what Mahesh is doing, Naresh is doing that inside the same project, inside his own inside that project A directory, he's maintaining a two separate directory by name prod and stage. He's doing it the testing. So till here, are you clear, sir? Because I have not yet come to the locking mechanism still. I'm just explaining in a very high level. Though this concept looks very difficult, but are you understanding it?
Yes, Rajesh, we are able to understand.
Yes. So now what is happening is that now you understand there are a lot of challenges are there again now, because what is happening that because even Mahesh and Suresh, even they want to do the changes into the stage itself, right? Even once they do the changes, even those changes and all, whatever they are doing the changes, again they want to do their changes into the prod. And again they want to do the changes. You know, you understand that every engineer will be doing. So it means that they are separately working on this Terraform file on both stage as well as the prod directory. Correct? So there are a lot of challenging tasks are there here actually. So what happens that there are two solutions which is provided by there are two important solutions which is provided by the Terraform itself. One is that actually to maintain its own storage to do that here. Okay. Now what will do right actually? Okay. So before this prod and also prod stage and all, what happened? The earlier solution was that actually we were working on the S3 bucket, correct? And you created a bucket, and by default it provides a versioning and everything, right? But assume that at the same instance, if both the users are accessing the same Terraform state file, it means that if they're trying to do, both of them are trying to do the changes and they're trying to do an apply, it should not allow it. There has to be some kind of a locking mechanism. Okay. So we had that issue also, right, earlier, right, where there was no locking mechanism when it comes to GitHub. Everyone trying to do a push and pull. So it was, no, those files were getting into inconsistent. And even like, no, there was a big fight between all these three engineers because they used to tell that I did my changes. He will say that I did the changes. So there's a lot of conflict arises between all the engineers, right? So that should not happen because there has to be a proper locking mechanism where at any one point of time, only one user can do a changes. The other has to wait till the lock is getting released, like that actually. Okay. So now for that, what happened, right? You have to implement the locking mechanism in AWS. We need to create one database by name DynamoDB. You need to create a DynamoDB database. So in the database, you need to create one table actually, and in that table, you need to provide some key actually. What is that key? That key is something with the name lock ID. It will be something like this way, lock ID. It will be in the same name, lock ID. So this lock ID also you will be showcasing here in your Terraform.tf file. It means that here, if you see it carefully, see, I'm showing here also. See, DynamoDB table, Rajesh. This is something like a lock actually. This is something like a key, and this is the DB. So by implementing this, what you are trying to do now, you are achieving a lock actually. It means that if the Naresh he is trying to do a changes into the Terraform-Day-8 file, whatever automatically a lock will get no assigned to this Naresh, and he will happily do the changes to this S3 bucket. At the same instance, if Mahesh is doing, Mahesh will not be allowed to do it. He has to wait till the lock is getting released or till Naresh completes his task. Because Naresh has to complete task means he will basically try to do an apply. Once he does an apply, and what will happen that he'll try to return the value, and that new latest value will be having a Terraform.ts file. And then finally, what happen? A version will happen, a backup will be created, a new file will be the name with the Terraform.ts file with the new data will be there. And finally, the DynamoDB will release the lock because Naresh has complete task. Now what happened? Mahesh can go it, and Mahesh can also work on it. And while working on it, this DynamoDB with the help of a DynamoDB lock actually, it's a table lock actually, it will lock to this Mahesh user. Mahesh will also do the changes into the Terraform.tf file, and he will try to do an apply. And once it applies, right, what are the changes are there, that will be written as a value, and it will be saved in the Terraform.tf file. Before it changes, it'll try to take a backup because S3 itself will provide the version. It'll take a backup or it'll maintain a version. Like that, this lock plays a very vital role when you're working in a project because there are multiple people who are working the same project. So you got it, sir. There are two important things where that you need to create an S3 bucket as well as you need to create a lock. Okay. You can forget about the prod and stage later. Later I'll explain this. But this is also one of the use case, right? Because you should not do all the changes in the prod directly. You are not supposed to do that. First, you need to do the changes to a stage, and then you need to do the changes to the prod. That's how it works actually. Sir, I hope that you guys understood the theory concept of this Terraform state file, right? So what I would suggest that I would not go with the practical now because it will be too much for you guys. So I thought I will cover up this entire theory. So till now I have not yet come to this picture, sir, where prod and stage are explaining. What I will do in the next session or the next class, I will explain about more in detail about this prod and stage, why we have to create it, what is it. Anyhow, you got some idea now, but I will explain in a more in detail manner so that you will get cleared actually. Your information will get your all your doubts will get cleared actually, right? So you know very well that because that my I'm just telling you, Naresh is maintaining a separate directories as a prod and stage, right? Again, for the prod you need to create a separate S3 bucket, you need to create a separate DynamoDB lock. Again, for the stage, again you have to create a separate S3 bucket, and you need to create a separate lock ID. So this you are knowing very well. It means that both these are two different environment. To maintain it, actually what is happening that you need to have the same bucket as well as the lock ID or the DB DynamoDB. You have to create separately. This is also one of the issue actually. You are maintaining it separately. Why can't I have only one S3 bucket where I can with the one S3 bucket I can easily manage? So to do that, what happened, right? Terraform intern is giving one feature known as a workspace actually. It provides a feature by name workspace. This we will discuss in the next class, sir. Right? So we will continue from here, sir, from the stage and prod where we did, right? From here we'll continue and we will get into the workspace thing. What is this workspace? How it will avoid to create more than one bucket? With that, in only one bucket you can play all the things. Okay, what is this workspace? How you can create different workspaces? Okay, those things and all we will be discussing at the later point of time. Clear, sir? Till here, are you clear? I know for some of you it might have you might felt today difficult or there are a lot of concepts are there in it. But once we do a practical, right, everything will get cleared, sir, for you. Means that you will not get any doubts. Actually, the theory part is more actually. Practically, it is a very small actually. You can everything can do in 10 to 15 minutes. You can showcase all these things so that it will be very easy. At the end of the day, you will see that the whole implementation is very simple. So that's how, sir. Theoretically, it is little complex, but practically do it, it is very easy. Clear, sir? So I hope you understood today's session, what we did. We will continue the next session. We'll try to do some more understanding on this, and then we'll land into the practical. Okay. So these two are important, sir. Whatever I told about stage and prod, right? So to maintain a separate environment, this is what they'll ask in interview, and they'll ask the interview about the what is a workspace, how you maintain a workspace, what is a workspace, how it will be used, the workspace between these three different users, how the workspace can be used. These are the things which they ask in interview. Clear? Okay, guys. I hope that today's session, you understood few of the things, right? So in the next session, we will see how to do the practicals. Okay.
Sure, Rajesh.
Okay, sir. Chalo then. Thank you, sir. Thank you all.
Yeah, okay.
Thank you.
Yeah, if you have any doubts, let me know, or else we'll stop the session. No? Okay. Yeah. So somebody can stop the session, stop the recording, sorry. Naresh, can you stop it?
I am trying, sir, but it
What about others?